Take it away, Anita.
Okay, great. So thank you for joining me today. My name is Anita Walls, and I'm the Assistant Director of Open Education and Scholarly Communication Librarian at Virginia Tech, or Virginia Polytechnic Institute and State University. Part of my work involves supporting instructors in creating, adapting, and sharing open educational resources. I want to share with you some of the problems and solutions that I, with some others that I've leaned on for assistance in an exploration of math and accessibility have experienced. I'm assuming that you're here because you also have questions about the accessibility of math and OER for people, especially those with low vision, and looking a little bit at the attendee list. I know that some of you have tremendous expertise to offer, so I welcome you. I am still learning, and I welcome you as learners and as contributors. Can you see my screen?
Yes.
Yes, okay. I do not see the green box. All right. So very first, I want to acknowledge the contribution of several colleagues from Virginia Tech and beyond. My colleagues, Corinne and Robert, have long been interested in accessibility and have contributed greatly to my knowledge of accessibility. Krista Miller, who's the Director of Inclusive Media Design at Virginia Tech, Ed Beck from SUNY Oneonta, Talia Anderson from Washington State, Apurva Ashok of the Rebus Foundation, and Volker Sorge at the University of Birmingham have all influenced my thinking in these areas. So thank you very much for your help there. So just a brief framing, we only have 25 minutes. 5 minutes, we're going to do a getting to know you exercise. I'd love to know about your level of expertise with math and accessibility, as well as what you hope to learn in this session. I'm going to talk briefly through a philosophy of accessibility that's related to OER, but is also related to accessibility generally. And then the bulk of our time will be spent on case studies. I want to leave a few minutes at the end because I know that you will have things to share about problems that you've encountered with math and accessibility, and you probably will have some solutions that I have not thought about. I also understand we have 15 minutes for hallway conversation after the session, so I will stick around. I would love to learn from you and to talk with you about some of the things that you've been learning in this area as well. Okay, so I would like you to go over to this link, which is bit.ly/math OER. And I'm also going to go there. And take a moment and tell me a little bit about your level of expertise regarding math and accessibility. You should be able to get in here. You should be able to edit. So the link is bit.ly/math OER. So, okay, lots of people in here. I understand we have a limit of like 100, so I don't think we have quite that many people here, but great. And then as some of you have already started completing, what do you hope to learn from the session? And we can come back to this as well. So I'm seeing some comments on issues to consider when designing OER math texts, how to help math faculty on my campus who want to adopt OER, tools for making OER accessible. That's a good one. Information about process, accessibility of animations. Ooh, we are not covering that, but I would love to talk more about that afterwards. How to make equations accessible, generally speaking. Maybe how accessibility is different for OER versus not OER. Tips for equations in press books. Okay, balancing accessibility versus giving math or giving answers. We'll have to talk about that a little bit more. LaTeX, preserving accessible formulas when going from Word to PDF. Ooh, we will talk about that. Adapting for accessibility and supporting faculty in the same. Okay, this is really great. You're welcome to keep adding things here. I'm going to move the screen over and go back to the slides. But I look forward to following up further on that. Okay, so accessibility involves two things: how learners with disabilities gain equivalent access, and how content developers enable content systems to function in ways that are compatible with assistive devices used by learners with disabilities. So as disclosure, I'm presenting from the perspective of a content developer who is thinking through how individuals with low vision and those that are blind can access specifically math-intensive learning resources through screen readers. I want to reiterate that navigation, headings, alt text for figures, scalable font sizes, color contrast, these are all really important accessibility features for low vision, but they're outside the focus of this talk. I also approach this topic from the understanding that if we as OER users, creators, and adapters are creating math-rich but inaccessible publications for people with low vision, we're creating unnecessary, unhelpful barriers that make it harder for intelligent, hardworking, and differently abled people from having access to resources that they would use to reach their goals. So it's my hope in this presentation that you'll begin to resolve issues that you may be dealing with or thinking that you might encounter as a content developer. And I hope to encourage additional work in that area. I don't know everything, and I hope that those of you who are more knowledgeable than I will jump in at opportune points to clarify or expand where needed. Okay, so some other aspects of the accessibility philosophy. Building things to be accessible takes a level of effort, but it's not only our level of effort in building things that are accessible. We need to make sure that we're building them in a way that they can be adapted, and the adapter has a reasonable level of effort to expend on this. So how do we make this easier? There's an example of things that are bolted on. So maybe you, as we did at one time, put accessibility as the last step in a process. You know what happens to last steps? The calendar, the budget, you run out of time, you run out of money, doesn't get done. So I'm proposing an alternative of baking in, this is for all the people who've been making sourdough during the pandemic, of baking in accessibility into the creation process, into the adaptation process. So it's part of, it's not the frosting on the top, it's not the extra thing that you do at the end. It's something that is a characteristic of the created thing. Okay, so I want to go into 4 examples. These are the case studies that we're going to look at. This example came to us in WordPress from an OER adapter who moved from another institution. We moved it into a platform that's based on WordPress, but we weren't doing anything in WordPress ourselves. So the equations in this and other figures are embedded within an image. And this one is actually really fun. It illustrates the story of how many times, about 600 times, a Thanksgiving turkey would need to be dropped from a certain height in order to be fully cooked. This is cooking with potential energy. Not very nice, but my initial thought was the author clearly has a sense of humor. Let's keep this. It's engaging for students. We can write alt text for the graphics. But wait, the relevant equations are embedded in the graphics. Screen readers can't read the math, and there's divergent thinking about writing alt text for equations. How do we make these accessible? So my disclosure here is we're not done yet. We were able to find someone who, at the time, who would write these equations as LaTeX for us and try to make them look like the figure. I don't think we've been successful. We're still toying with how do we present this in a way that is as engaging and interesting as the picture, but how do we present it in a way that screen readers can actually read? Okay, second example. This manuscript was written with some obsolete software called FrameMaker 7.0. You might know FrameMaker as an Adobe product. This is before it was acquired by Adobe. The PDF output looks great, but screen readers read text, not equations. They also, anyway, let me show you what happened when we reverse engineered it, because, oops, wrong one. Okay, so we reverse engineered this and we discovered that there are all kinds of pieces in here. There are equations that look like this picture. There are lots of bits. In fact, each of these little arrows, each of these emphasis marks, and I'm sorry, I don't know what these are called, each of these appear as a JPEG. So we are not able to reverse engineer this into anything to get coherent source files. Our goal is to make it both accessible and editable in software that's not 20 years old. So we have a few different options. One is to rewrite the whole thing in LaTeX. Another is to use MathML. Do we put it in LaTeX? Do we generate an EPUB? Oh, and the manuscript is several hundred pages long. So we have several problems here with the math not being readable, with the figures not having any alt text, and being, frankly, to the degree of complexity that this would be very difficult to describe in the number of characters that alt text would allow you to use. This is a current project that we're working on, and I think we're defaulting right now to writing in LaTeX, and we're exploring some semantic options. For example, creating the figures in SVG, so they have data that a screen reader could read if it could read data and not just text. Okay, so next example. This is an original authored open textbook. The URL is at the bottom of the screen if you want to see more. In this example, the author wanted to write in LaTeX. This is his native language. He is amazing with regard to writing in LaTeX, but not everyone wants to know or knows how to compile LaTeX. So it's helpful to have a PDF. Well, at the time of doing this project, we did not realize LaTeX is machine. We did not think LaTeX is machine readable. This is your accessible version. Do we even try to make the PDF accessible? We didn't know. Perhaps we would not have tried so hard to make the PDF accessible. But we did try. What did this take? We embedded the alt text for the images within the LaTeX and then tagged it to allow a certain kind of screen readers that read deeply and others that read on the surface to access the content. I thought that we had tagged the math to do the same thing. However, my understanding is that it's very acceptable to tag a PDF to say there's an equation here and not tell you what the equation is. very, very frustrating kind of experience to realize that you have produced a whole book that is in PDF that has all the navigation, all the alt text, all of the tags, but to realize that no one can read the math if they're reading a screen reader, and math in this book is pretty important. Okay, so a fourth example, and this is the last example. This author is writing in Microsoft Word. The author wrote out the more simple math using some non-scientific characters. The author also includes JPEGs for some of the more complex math. As you may guess, layout is a bit of a nightmare in Microsoft Word, and the source files will become obsolete as Microsoft rolls out new versions. So the items that are highlighted in yellow also are things that did not import correctly because of the type of character they were. So we have gaps in these equations where we've had to identify and fix them as well. So lots of different issues with manuscripts. How did we deal with this? Oops. Whoops. Oh boy, we're going back to the front. Sorry. Okay. So let me see if I have one more. All right, we'll come back to this one. I think I have a slide a little bit later on. So you'll notice that in many of these instances, the math renders as a picture. The math may have been created by a lot of different authoring tools, and it was displayed. The overall package was a lot of different things. So you might have PNGs or JPEGs in HTML. You have other containers that are PDFs or Word. In 3 of the cases, none of the math is editable, but in 1 of the cases, the math is editable if you have the LaTeX source files. So what kinds of solutions are we seeing right now? We're seeing reader side solutions, which are quite interesting. There's.
Thank you.
Sorry, I'm getting some extra sound from somebody, I'm not sure where. Reader side solutions where a screen reader can translate equations with a high level of accuracy into spoken or Braille code, or an interactive keystroke navigated semantic environment that the person with low vision speaks words or code that the person with low vision understands. This is an emerging sort of accessibility tool. The company that's working on this is called progressiveaccess.com. This is Volke Sorger's company. And they're doing a lot of really interesting work with data that you can read from images and from math. So what's important here is that images and math or visual kinds of things have as much data and as much semantic structure preserved. So this is where SVG is important instead of JPEG or PNG. We're thinking, what's the data rather than what's the data that I'm getting through my visual senses. So second solution is the content developer side. And that's where a lot of my challenge has been. So equation images need some form of content that a screen reader can read. So most of the solutions that I'm seeing indicate that PDF is not a great solution. You want HTML output or you want EPUB. If you can build your math using LaTeX, ASCII Map, or MathML in a MathJax environment, you can generate the HTML and the cascading style sheets. If you use LaTeX, Word, Markdown, and Pandoc, generating math in an HTML environment is much more friendly. So on the right, you're seeing how this particular equation, which I think you saw before, is represented. This happens to be in Pressbooks, and it's a what we did here is to use a tool called MathPix, which I will pull up right now, to identify what the equation is. So I took a picture of the equation. Oops, no, not right there, right here. Okay, let's try again. So I took a picture of the equation, and it gives me the code in MathML. It gives me the ASCII math as well as the SVG. I can pull this code into the back end of my publishing system, and it will represent the kind of figure that I have there. Does it always work perfectly? No, it doesn't. There are times when, okay, you can't see this. Okay, there are times when you have to fix something in here. And so going into the MathML, trying to understand what characters do what is a helpful thing to work on. Okay, so, and there's MathML. Equatio is a commercial, these are both commercial, but MathPix has a lot of sort of free snips kinds of things. Equatio is a tool that my university subscribes to, pays for, that allows you to edit and insert math. I have some colleagues who are exploring using this in conjunction with Grackle Docs to make things a lot more accessible.
Anita, don't forget to leave a little time for Q&A, please.
Okay, so let's, I'd love to talk with you about what kinds of solutions, problems and solutions you're encountering. So let's hop over to the interactive part, and thank you, Jonathan, for cueing me on the Q&A. So I'm going to hop over into the collaborative notes again, and would just love to hear from you about what kinds of problems you're specifically encountering, what kinds of solutions you're learning about in this session, and then other practices and solutions that you found helpful. I'm also going to open up the chat because I can't see it right now. So, okay, so Adobe is to be avoided, okay.
Anita, can I ask you a question?
Please.
So I've been working with the math faculty, chemistry and biology, and it's a big problem with the equations.
Yeah.
The constraint we have is we don't have the commercial tools.
Mm-hmm.
And also we don't have the commercial screen readers. Or actually, I have downloaded JAWS, but I'm trying to work with tools that most everybody can have access. So open tools, you know, as well as producing products. And what I found is that the math equation never reads right, even though, you know, even though they says, I tried, and maybe I don't know how to use these screen readers, but I'm finding it very difficult. But what I did was I tried to learn the syntax, the grammar used by the screen reader, and then make a figure and then write out the equation, you know, as alt text. And I was wondering, you know, if we could share, but then I came across certain chemical equations, and I asked the faculty, well, how do you read these equations? You know, and they couldn't tell me. So I was wondering if we could share how we do the alt text for some of these things as a short, you know, interim measure.
Yeah.
Because until we get to better solutions, we're relying on alt text.
Right. So with chemistry, I think that's not an area that I know very much about. The progressiveaccess.com people are working on the semantic tools for being able to understand how one bond is connected to another bond and how many, how many positive or negative, sorry, not a chemist, how many of those things are on there. I would love to hear what, if you have something that you wanted to refer to describe your approach, I think that would be helpful. Yeah, math type is, Paula, do you want to say a little bit about math type? I'm seeing, she said, I've worked with faculty who've created their equations in math type in Word, and then they export them as HTML and MathML so readers can read it. Jonathan, do you or anybody else here know about open source tools for screen readers? Are there such things?
I can speak to that. Hi, I would recommend NVDA.
Mm-hmm, mm-hmm.
Oh, there's David.
Yeah. Okay. See, I'm not strong on the screen reader side, but other stuff I'm learning. So, I'm going to add NVDA as in the practices and solutions. It looks like there's some other comments about.
So I'm sorry to jump in, but I think we've hit the official end of the time, which is great. But there's this room is definitely available for people to stay and chat with each other, with Anita, for the next 15 minutes. I'm going to turn off the recording though, and
Okay, that's great.
And please stick around if you want to continue the discussion.
Yeah. Can people unmute themselves?